Morning. My name is Greg Hayes from Torrey Logic, and we do have a table over here with Tian and with some equipment and specs and brochures on the items I'm talking about. Torrey Logic is a small little company in San Diego, right north of the airport in Del Mar, and we do a lot of custom niche products for primarily the SOF community, a lot of the guys in Coronado, the Navy Special Warfare and others. The topic today is called Lightspeed. It's a family of products that we have developed over the last 10 years that all have the same principle, and that is that there is zero RF in these units. They're 100% free space optics. They're not affected by EMI interference. They are extremely covert, and I'll explain that in more detail. They do work in areas where traditional RF is jammed or denied or not desired. These guys are in a variety of formats. This one's probably the most simple. This is a standard binocular. It's made by a company called Leica, a very reputable binocular. What we've done is we've actually modified the top of the binocular to house 3 AA batteries. And then on the side, this bump here actually is a light-emitting diode, an LED. So all of our communications for Lightspeed is actually done without lasers. We're 100% eye safe. We use all LEDs. We do them in frequencies all the way from ultraviolet all the way to thermal. So we've done stuff with visible lights. We do stuff a lot with sort of the near IR. This guy right now has a near IR frequency in it. So what happens is this LED actually pulses and goes out the right ocular of this binocular. It goes out the entire field of view. So this guy is a 7-degree binocular. This is functional up to 5 kilometers. So at 5 kilometers, somebody's on the hillside or on a ship or on a rooftop, I'm seeing a 7 degrees at 5 kilometers, which is several football fields wide. I don't care about stabilization. I don't care if that guy's rocking and rolling or I am. As long as I see him through here, he sees me, we're connected. When I say we're connected, what we're doing is we're passing full duplex audio. We have a headset on here. It's very high-res or high-quality audio, and we're passing data. There's a little USB plug here. We do full-blown Ethernet, USB, serial, analog voice, analog video, a variety, basically any format that a soldier would have on any device. This guy actually does a receive on this end and a send on this end. So a lot of questions we get is, what's the effective environments? We work in rain, fog, dust. All that is particles in the air. Keep in mind this field of view is extremely wide. So nothing actually blocks this except for very, very dense fog. The Air Force have actually, the Navy has taken us through a lot of environmental testing with the Air Force climatic chamber down in Eglin, and we actually did show the effect of fog. We defeated the sun in the background on both sides. We have all the test reports, so it's very robust. This unit here is being used by a lot of the SOF community. We have devices that you'll see there on the slides that are used by the bigger Navy. These guys go long range. This is a unit that actually goes about 40 kilometers. So if you're trying to cross the water or a rooftop to rooftop, just plug it in. It's got Ethernet direct. You can do voice, you can do data, live video. We're doing this for the big Navy. When they are at sea with 2 ships, they're in a condition called MCON, which means they got to turn off all the RF devices. They can actually fire our guys up, not only do a communications link, but also extract the distance between the devices. It's very useful when you're doing things like refueling at sea, where you got to maintain separation. At the same time, you're rocking and rolling, and you're in a condition where RF is not allowed. We also do body-worn systems. The same optical solution, Lightspeed, is actually done in little matchbox-sized devices that are used to place on the body to eliminate the cables on the body. So we're doing this for the guys at the AFRL, the Batman project. So the TACPs want to get rid of all the cables on their backs and necks and connecting the neck to the head and all that stuff. So now we're using an optical solution. Works all the time, works underwater, works in all environments. There is no issue. I know the Army has chose a non-optical solution here with ultra-wideband. I mean, we think this one has been extremely successful. We'd be happy to share more details. We're doing, significant ranges on the body from the weapon to the heads-up display, from soldier to soldier, inner soldier. We do full-blown analog video now. This is another one here that we're doing underwater for the seals. So keep in mind, like I said, our frequency of our LED could be in any frequency of light. So underwater, obviously, we go down to the ultraviolet type of ranges. So we're doing projects now with the Navy to go diver to diver communications, diver to platform, diver to buoy. We even got devices that actually transition from underwater to out of the water and actually switch frequency to go from a UV to a near IR so they can maintain communications and data all the way through. So I got plenty more slides on this. Here's another example of, I mentioned to you about our ability to extract distance. So say a small UAV was trying to land on a moving platform. I mean, now it's pretty much a controlled crash. So what we've done here is actually provide an optical link where the UAV actually gets relative position to the landing gear and actually can adjust as that unit is either, say, the back of a truck bed or the deck of a ship. So that's, I got plenty more slides, but I'm not going to change topics here. So any questions on Lightspeed? Over here we have a pair of binos that are working. We have the device we're doing for the big Navy. We got the body worn system that's showing some video links, and we got plenty of brochures and specs, and welcome you to come over.
Okay, I'll take the first question. Do you have retrans capability?
Retrans.
So the idea is if, you know, I know it's line of sight, but if I can just, I'm thinking about perimeter and tower to tower.
That's a good question. So we do get the line of sight question a lot. There's a couple of solutions here. One is we make an omnidirectional device that actually can be transmit and receive from any direction. The challenge with that is you typically lose distance on that guy because you're not focusing the beam, you know, through a set of optics. However, like in your case, is if you and say this gentleman had a brick wall between you, but you could both see me, right, then we actually can carry a, you know, it's a bent pipe. So we either can all be on the same channel and actually have a conference call if it's like a team of guys, or you can just use me as a relay and connect to them. So we do multi-channels. We do a variety of solutions in that case.
And did you mention the bandwidth limitation?
Yeah, so it is contingent upon a variety of things. I mean, the size of the optics and the power, but typically we feel very comfortable both underwater and above water to say a standard 10 megabits per second. So these guys, you know, like the binoculars, for example, I mean, you're only carrying a couple of AA batteries and this guy, so we feel like 10 megabits is plenty. I mean, it's full HD video, it's multiple voice channels. We have units that actually go, you know, into the 80, 100 megabits things, but keep in mind that we are LEDs, we're not lasers, so we're not going to go after the gigabit enterprise type solutions.
And then do you have a diagram that can say from a size, because everything is size, weight, and power.
Yep.
So if I took the equivalent on the RF, and whether it's a transmitter or receiver, if I do the size and weight and power comparison,
yep,
where do I stand on those features?
So, you know, we do a link budget just like the RF guys do. If somebody comes to us and says, hey, I want to push X amount of data, X amount of distance, then we tell them what, if they want to have truly the same unit on both sides, we'll tell them the size and weight required. I mean, like I said, this guy will do, you know, 10 megabits at 5 kilometers. We have devices that are not much heavier than this, that do the 40 kilometers. But what we also have is the ability to have a true asymmetric link, meaning that if you just have, say, a strand of fiber that's doing omnidirectional, then you're very, low in terms of your power and your size. The other guy can actually compensate for it. So I could actually have a telescope and be, you know, several hundreds of kilometers away to make up for your lack. So it could be truly asymmetric depending on the application.
Okay. Any other questions? Okay, sir. Thank you so much.